Welcome everyone to the webinar Simplifying Spinnaker, Deploy Spinnaker Pipelines in Kubernetes. We're going to start in a minute or so. We still have people joining. Thank you for attending today. Welcome everyone to the webinar Simplifying Spinnaker, Deploy Spinnaker Pipelines in Kubernetes. My name is Mark Levy, and I will be your host in today's webinar. I focus on product marketing here at OpsMX. Before we start, a few housekeeping items. The session today is about 50 minutes long. We are recording the session, and we'll be sending the recording and the slides to anyone that requests them. Please ask questions in the chat, and we'll stay and answer as many questions as we can. Before we begin, I just want to bring you a little bit about OpsMX. If you can go to the next slide, please. We are dedicated to making the process of continuous delivery easy and successful for you. We have a large number of customers of every size, from the most sophisticated, including customers like Salesforce and Cisco, to organizations who are now highly successful, even though they had little or no continuous delivery experience when we started working with them. So please check us out at opsmx.com. And also what we'd like to do too is learn a little bit about yourselves. I'd like by doing a poll. So I'd like to launch a poll and ask a couple of questions first. If you could answer them, we'd be much appreciated to understand what your background is, how are you considering Spinnaker or using it, and how you're deploying to Kubernetes today. I think that would give our speaker more insight as he gives the presentation. And while you're doing that, I'd like to introduce our speaker today, Srini, who's the head of customer success today. Srini has 20 plus years of experience in software architecture, design, hands-on development, testing, implementation, and maintenance, both in agile and waterfall methodologies. How are you doing, Srini?
I'm doing great, Mark, and all set to deliver an interesting webinar today.
Okay, so why don't we wait give another 20 or 30 seconds, give everyone a chance to fill out the poll. We would really appreciate it. And then it's over to you. So we'll end it in about 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, there's our poll. And why don't you take over, and over to you.
All right, thanks, Mark, and thanks everyone for joining us today. So I'm sure most of you have heard about Spinnaker. It's open sourced by Netflix about 5-6 years ago now. And it was designed and built ground up for deployment. And it was born on the cloud. It uses most major, latest technologies, microservices architecture, API-based architecture, and so on. It's built, custom built for deployment to cloud and Kubernetes. This is used by thousands of companies world over, and it's battle tested, extremely reliable, and designed to make sure that when we say an application is deployed, it is actually deployed. That is to say that the users of the application are able to access the application, not just we issued some command and the command returned success, and therefore we say it's deployed. Now, Spinnaker makes sure that the network traffic goes to the application. It ensures it plugs into the infrastructure, so it is able to make sure that the network traffic is actually flowing to the application and that the application is responding. So some of the key features of Spinnaker, it has models that map Kubernetes concepts such as load balancer, ingress, and deployment, and so on, with the platform terminology. It also provides built-in support for advanced deployment strategies such as canary, blue, green, and so on. So this mechanism is built into Spinnaker. It's cloud native, as I mentioned, that it was born on the cloud. It's not something that's a retrofit, something that was there and then Kubernetes came along and say, yeah, sure, we have a plugin for Kubernetes. No, it was built, custom built from ground up for Kubernetes, on Kubernetes. Spinnaker runs on Kubernetes. So it's a complete first-class support for cloud resources and Kubernetes. And then a lot of best practices are kind of built into the tool itself. For example, making sure that your artifacts are in a Git repository. Of course, you can put it directly on the screen UI, but in case you want to version control your artifacts in a Git repo or something, that is very, very natively supported. And we'll talk more about that. So this is just a very high level overview of what Spinnaker is. It's highly scalable, very, very reliable, designed to be fault tolerant, high availability, and so on and so forth. So many of you might have had some experience with Spinnaker. That's where most of our customers come from. And Spinnaker being open source, it comes with a few challenges, the most important of which is installation, getting to the UI, the initial configuration, infrastructure configuration, and so on. So a lot of people struggle with just installing and getting the UI up. And then configuring accounts. An account in Spinnaker is essentially permissions. So you may have one Kubernetes cluster and have multiple accounts, let's say separated by namespace, or you could have multiple clusters. And then artifact sources. Artifact sources could be your GitHub, Bitbucket, S3, Amazon S3, or GCS, what have you. Place where we typically store files. And these are, it could even be Helm repositories, for example. And then similarly, though not mentioned on the slide here, your container repositories, GCR, ECR, or you have JFrog, container repository, Artifactory, whatever. So each and every one of these configuring requires backend configuration. It requires someone to go into the backend, make some changes, do a HAL deploy, apply command, and then users can use it. Once we are past this, getting Spinnaker to be production ready is the next level challenge. Particularly when we are scaling, we want resilience. We need to know what is happening. So in a microservices architecture, Spinnaker is composed of somewhere between 7 and 10 different services, depending on how you configure it. One of the services may be choking on CPU, or there might be some network delay causing things to fail, and so on and so forth. And these things typically don't show up in the initial testing at low loads, but as the loads increase and the number of applications and the cluster sizes increase, it becomes more and more evident. And a lot of people, a lot of our customers come after they have struggled, with a lot of production configuration, and then, it requires a lot of expertise. And OpsMX, we are of course the Spinnaker experts. We are one of the largest contributors of Spinnaker source. We are able to make modifications to the Spinnaker source ourselves. Our company includes people who are approvers and reviewers for Spinnaker open source. And then finally, when we actually try to do the blue-green deployments, let me put it simply, it's not easy. Some of you might have heard about Kayanta, which is a Spinnaker component for blue-green deployments, and it supports only Prometheus and Datadog. So if you have your metrics data coming from somewhere else, basically it's tough luck. Not to mention that it analyzes only metrics and not the logs. So this is where we are with open source Spinnaker. Fantastic tool, extremely capable, with a lot of interesting features. It has very, very advanced flow control, pipeline configuration with conditionals and all, conditional expressions and all, which I'll show you at some point. But the challenges are really in the starting, setting up, installing, configuring, and using. It's not as smooth as one would like it to be. So what are the ways we can simplify Spinnaker and use it for deployment to Kubernetes? Here at OpsMX, we have come up with a simplified installation and production configuration. So when we install, it's pretty much production ready with monitoring, alerting, self-tuning, self-hosting, automatic backup of pipelines, and so on and so forth. All that is configured automatically, and the whole installation is over within an hour, typically half an hour, 40 minutes. And you have the UI up and running. So the entire installation process has been simplified using automation, using various scripts, custom jobs that do a whole bunch of other configurations, and then making the production configuration and production installation very simple. Apart from that, of course, we also bring the knowledge needed for production configuration, depending on the scale you are looking at. We have predefined templates as to what should be the size of different components, and so on and so forth. The other aspect which I mentioned was, if an account needs to be created, or if an artifact needs to be added, or artifact repository needs to be added, it has to be done by someone who has admin access on Spinnaker. What we have done is that we have a UI-based account creation, addition, deletion, creation of artifact, container registries, and so on. What this actually does is that essentially this moves it to the developer self-service. So the team that is handling Spinnaker, which probably has admin rights on the cluster and on Spinnaker, doesn't need to do all this. Users can go create their own accounts, create their own artifact repositories, and deploy artifacts, maybe a Helm chart, or maybe a deployment YAML file from their GitHub or S3 bucket or what have you, to their own Kubernetes account, without any effort on part of the people or the team that is handling Spinnaker. So a very good part of developer self-service is taken care of. And this includes RBAC, role-based access control, that Spinnaker natively supports. And the role-based access control is extended here, so that kind of ensures that one person cannot go and, cause damage to an artifact or an account that has been created by someone else. So with role-based access control, with UI-based configuration, it is very, very easy for developers to use the system themselves without having to rely on, on another team that potentially has, full access to Spinnaker. One of the other things is Spinnaker supports custom stages and custom integrations. While it does come with pre-built integration to a lot of other systems, it is entirely possible that in your environment there is something and we need to integrate with that. Very common use cases, Terraform, Ansible, and so on. So what we have done is that we provide you all those, we have about 30, 40 custom stages that are pre-built, and they are available in a default installation. But what we have done is that we have created a standardized custom stage, bring your own script, as we call it, and doesn't require the users to start from scratch. They just need to write the script and provide the container image that's going to be run, that's going to run that script, and done. So this mechanism makes it very, very easy for developers to create custom stages, custom integrations with your own systems. And while I'm speaking, if you do have any questions, please go ahead and enter your questions. And then, I'll answer all of them towards the end. And then we do have agent-based deployment. This is slightly, I just touch upon it. Essentially, we have, this was originally developed for a SaaS kind of a model, where OpsMX will host Spinnaker, and then customers can deploy to their Kubernetes clusters without giving us their kubeconfig file. But this has found traction in companies where, let's say there is a team that does the production deploy, and there's another team that handles Spinnaker, and this team that does the production deployment does not want to give access to the kubeconfig file or access to the production cluster to this team that's supporting Spinnaker. With agent-based deployment, it becomes possible to have multiple clusters, deploy to multiple clusters without any access to the secrets or the kubeconfig file or Jenkins or what have you in that cluster. So this is a very interesting use case that some of you might find very useful, where multiple departments are there and each has their own account, let's say maybe their own cluster, and they want to make sure that come what may, another team is not using their cluster, for example. This has also been one of the common use cases we have come across. And then what we have also done is sample pipelines. So our default installation includes our 20 to 40 pipelines that cover most common use cases. So I show it in the demo. So when we start with the OpsMX Spinnaker, it becomes very, very easy for people to refer to existing pipelines that typically work to figure out how to deploy their applications. So this is really the core of what we have done to Spinnaker, make it easy. And these are only the top 6. As we mentioned, there are a lot of others things that we have done. For example, as I said, we have built-in Terraform's custom stages. We have integration with Jira and ServiceNow and so on and so forth, most of which I will probably not be able to go in this particular webinar, but I'll probably touch upon them. I just quickly touch upon the intelligent software delivery platform that is built on top of Spinnaker. And it has all these things: approval, policy, intelligence, visibility, and so on and so forth. But what I like to touch upon is the continuous verification you see on the top right corner. This is nothing but the next generation of Kayanta. So the architect and designer of Kayanta, Michael, is in our company. And what we have is really the next generation of verification. So the way Kayanta works is that it compares metrics to see between in a canary or a blue-green between two sets to see whether this is my original one, this is a new one I'm trying to deploy, and if my metrics have deviated beyond a certain, beyond certain percentage. What verification does is way beyond that. It has, of course, metrics. It also compares logs. It has machine learning algorithms and statistical algorithms that does clustering on the logs and pattern matching, natural language processing to logically compare two sets of logs as well. So logs and metrics, and logically compare the two. And this results in a host of use cases where which can, apart from canary blue-green strategies, it also helps you debug quickly, identify one offending log line among millions of log lines, and so on and so forth. So this is a topic that we'd probably need a separate session entirely for to understand how the verification works. And multiple years of research has gone into this. And to my knowledge, this is absolutely the one of its kind in the world. But we'll talk about that some other time. So let me quickly go into the demo and show you what we have here. So let me just log back. Uh-oh. So I'm just going to show you very quickly how the UI integration works, and and how we can very easily look at the configurations. So let me start by showing you that. So you can see we have an integrations tab here, and pretty much all the integrations that are supported by Spinnaker are over here. Amazon, Artifactory, Bitbucket, Docker, ECR, GCR, Git repo, GitHub, GitLab, Helm, HTTP, and any other container registry. So all these things you can see in the UI, you can just configure it straight here. This is what I was talking about, developer self-service. Developers will be able to configure their own repository, container repositories, their own GitHub accounts, or their own Helm chart, Helm repositories, and so on, and deploy them. And then similarly, we have other integrations with Jenkins. As many of you might know, Jenkins is very, very natively integrated with Spinnaker. And you should be able to, configure a Jenkins account straight here from the UI. And as you can see, we have, Jira governance and a whole bunch of integrations. I'll not go into them today, but almost most of the configuration of Spinnaker that is typically done from backend, most common configurations are available straight here from the UI, including, for example, Slack configuration. The other aspect, as I said, was the account configuration. So if we look at how you would create a Kubernetes account in Spinnaker, it requires some backend work. Someone has to go issue some commands and so on. What we have here is a UI-based thing. Pretty much most common accounts, Kubernetes, AWS, Azure, GCP, you can configure them straight from the UI, and it's all set up for dynamic account configuration. So you don't have to do anything. You just hit the save button, and in few seconds, not few seconds, but in a minute or so, you can see this account reflect in Spinnaker, and developers can deploy to it. And as you can see, with the RBAC enabled, developers can do it themselves. So for everything, the team that's supporting Spinnaker, the central team, for example, doesn't have to do anything. They can set up the access control depending on who we want to give access to, and those people can go and create, a Kubernetes accounts themselves. So this is really the crux of the value addition, how we have simplified Spinnaker. And coming to Spinnaker itself, the default installation includes a lot of sample pipelines. And you can see that we have these many pipelines already installed. So whoever wants to deploy, let's say, a Kubernetes manifest, they can just go look here, see what a pipeline looks like. And we have two of these here. Let's take a quick look. The first one is deploy manifest. This is how it looks like. This is the manifest. You put it straight in the screen as text, and then you select which account you want to deploy to, and if it has multiple namespaces, you get to select which namespace to deploy to. And there's a very simple, straightforward way to deploy to Kubernetes. So when you think about it, with this kind of a mechanism already in place, we already have samples. So if you have a Git manifest stored in a Git, for example, in a Git repository, then we can do the same thing, and you can find that there is already a sample. There's a repo and this thing, and you can get it from an artifact, and you can select, and then you know that this is a working pipeline, and developers can just look at it and figure it out themselves, how they can deploy an artifact that's in Git repo. And similarly, we have one for everything. So for example, I think we have, let me take this out, let's say GCS. So we have, sample pipelines for deploying from a GCS. This is Google Cloud Store, GCS. For a moment, I forgot what that was. And you can see that if you want to deploy, let's say, a Helm chart. So we have the different ways of deploying Helm from a repo, from a Git folder, or from a chart, tar.gz. And for each one of them, we have a sample pipeline here. So we can go take a look how it is done, and then take this as a standard and go from there. So this really helps bootstrap the developers in getting started really quick in terms of deploying to Kubernetes from whatever artifacts they have, whether it is in in a Git repository or some file they have probably on their laptop. We also have customized So in case you are using customize, we have a sample for that as well. And you can see how customize deployment works with the samples over here. And let me, while I'm at it, let me quickly show you a few other interesting pipelines we have. One of them is a blue-green deployment using traffic shaping using ingress. So Spinnaker supports different strategies for deployment. Blue-green is one of them. So we have progressive deployment where we switch the traffic progressively from the existing one to the new one and see how things are going. And as we are switching the traffic, we are scaling down this old group, scaling up the new version, and also monitoring all the parameters and making sure that your customers are not being impacted. And then we have the Highlander strategy, where we simply bring up the new one and shut down the old one. So this is, all these strategies are natively supported. How to use them, you can find the samples right here in sample applications. Unrelated, but I just thought I wanted to show you this, that we have, we also have a Git PR trigger pipeline. This is a sample pipeline that's been simplified with what we actually use. So what we do is that in our development, whenever a PR is raised, then it automatically triggers a pipeline that, as you can see, checks whether the PR target is master, and if it is, then it goes ahead and builds the whole thing and deploys the code, and then it runs the tests, and if anything passes, then it does the automatic merge, or it notifies saying it's okay to merge. Otherwise, the tests fail, and the person is notified that the automated tests have failed. So this is what we use in our for our own development. And the reason we have put it in sample applications over here is that many of our customers have asked for this, saying that we need an automated process so that whenever a PR is raised, we are able to deploy and test before merging, and making sure that we have the, the basic sanity tests running, and keeping the master branch clean. So this is what we have. I did use self-tuning and self-hosting. So I'm sure most of you are aware of it, but I'll just quickly show you what that is. Let me start by self-hosting. So you can see here that there's an application called Spin. I go here, you'll find that Spinnaker pods are actually visible in Spinnaker itself. So you can go and look at cloud driver caching, and you can even look at its log. And this is Spinnaker's own log that you can see in Spinnaker. This is what we have. I think we call it self-hosting, but that's more of an industry name where an application is used to handle itself in a way. So this is self-hosting. And you can see that all of the Spinnaker pods, so you could actually scale. So if you really wanted to scale cloud driver caching, you can do it straight from the UI right here. I'm not sure how to do this, but you can do it from the deployment. You can scale it. And this is self-hosting. And let me also quickly show you what self-tuning is. So what we have done is that now, as we already have monitoring using Prometheus, we have set up arrangements so that the Prometheus alert triggers a pipeline, which triggers yet another pipeline, which goes ahead and executes a script that is going to change the parameters. If CPU is low, it'll go ahead and trigger a pipeline that will allocate more CPU to a particular resource. Similarly, depending on what strategy you want, if Orca is overloaded, for example, you could increase the number of replicas for the Orca pod. So the idea here is that it is self-tuning. As the load increases, it will automatically change the parameters. And as the load decreases after some time, you would also scale it down and make sure that even as your load is fluctuating, Spinnaker is not running out of resources. As you probably know, that if there is a choke of some sort, pipelines might fail, and developers could spend a lot of time trying to figure out what has gone wrong with the pipeline, only to realize that there is something in the infrastructure that's causing the issue. So this is self-tuning. As I said, monitoring and alerting is already included. Self-hosting. We also have DR and automatic backup. So maybe, okay, I'm on the wrong screen. So we also provide mechanisms to back up all your pipelines. So we have the sync to Git, which essentially takes all the pipelines, and in Spinnaker, pipelines are nothing but JSON files, and it extracts the JSON files and uploads to a Git repository. So if we set this up on a cron job, it'll automatically once a day or every hour, 2 hours, whatever you feel like, is going to back up all the pipelines to a Git repo. And that makes sure that even if this entire instance were to be blown away, all my pipelines, all my data, all my configuration, everything is in Git repo. It is not going to go away so easily. In fact, this entire configuration is also, Spinnaker configuration is also in Git repo. We have a GitOps style Spinnaker. So with this DR database backup, we have pipelines for that also. So the database gets backed up automatically. Pipelines get backed up automatically. You can see here sync to Spinnaker. Similarly, we have pipelines to restore database and so on. So once we set up this one, even if that entire cluster gets deleted for some reason, we can recreate this whole thing in a matter of an hour or so. So the DR part is taken care of. Monitoring and alerting is taken care of. Self-tuning, self-hosting makes it, there is really no reason for someone who is authorized to go to the backend. And that's roughly the theme of this, that we are making it very, very easy for developers to deploy this to Kubernetes, whatever they have, whether they are packaging in Helm chart or customize or whatever, wherever they are putting it. If you go and see the sample applications, you can also see Jenkins. So we also have sample pipelines that show you how to integrate with Jenkins. Once we have this, it's fairly straightforward. You can create an application, I'll call it, webinar demo, and then select this. You can select the cloud providers, but we have multiple of them. But if we leave it, nothing happens. We can decide who you want to give permissions to, and then say create, and we are set. Create the application. I'm wondering why it's not doing it. Let me just create the application once again. Web test. You select this, and then all right, something is preventing it from creating an application. Not sure, but you create an application and go here, create a pipeline and call it easy pipe. And then we can add stages here. It comes with a whole bunch of built-in stages. So you have deploy manifest. Kubernetes, select an account. We have a lot of these. And then we select a namespace. And then we copy paste your manifest over here, and we are set. So this is how easy it is to deploy to Kubernetes using Spinnaker. We have made it even easier to get started. The whole process to get started from A to Z should not take more than an hour, maybe less. For us, it takes only half an hour, but it really depends on how on the speed of the cluster and where the cluster is located in the world compared to where you are. So this is roughly what I wanted to demonstrate. Any questions, please feel free to ask. Anything else you want me to show, I'm more than happy to demonstrate.
Oh, great, Srini. Excellent. Thank you very much. And please enter your questions in the chat session. And while we're waiting, I'd also like to do a final poll just to let us know if there's anything we can help you with. So let's set up that final poll. If you can take a minute and formulate any questions for Srini. There's a couple coming in, and if you can also fill out the final poll question, we'd really appreciate it so we can better understand how we can help you. While we're at it, so there's a couple questions coming in. Srini, how are secrets handled? And the whole idea of secret management itself. Can you give some thoughts on that?
All right. So here, the purpose of this demo was to show how easy it is to deploy to Kubernetes. From an installation point of view, we fully support handling of secrets from a point of view of how secrets are used by Spinnaker for Spinnaker configuration, for secrets associated with, let's say, accounts, secrets associated with artifact repositories, and so on. And we support multiple backends. By default, we use Kubernetes secrets. However, if someone wants to use Vault, Google Secrets, S3, one of the common ones where people use S3 for secrets, these are all supported as an install time option. So when our customers install, if they want to use their own secret manager, then we configure it for them.
Interesting. Okay, so we do integrate with Vault and other tools as well. What about you mentioned agents? Do you need to provide credentials when using those agents? How are those managed?
Right. So one does need to provide the credentials. Without that, obviously the access to Jenkins or access to the Kubernetes cluster won't be possible. Only thing is these credentials are not provided to Spinnaker. They are provided to the agent. So the way the model works is that there is a controller that is sitting with Spinnaker, and then you have an agent that is sitting in your cluster, wherever that is. And the credentials are provided to the agent, not to the controller or to the Spinnaker. So the way it works is that Spinnaker does its job through the controller, through the agent, and the agent will add its credentials and send it to whoever the intended party is. It could be a Kube API endpoint or Jenkins or what have you. And in this model, there is no possibility of these secrets that have been given to the agent to go anywhere outside of that. There is absolutely no chance, and there is no reason to give those credentials to Spinnaker. So the credentials, the secrets are there, they are needed. Without that, access won't be possible. But users don't have to give it to Spinnaker. And that's really the common use case that we have, where we, I don't want to mention the customer name, but each customer, each department has their own billing account. with the cloud provider. And they want to be absolutely sure that the other department is not deploying to their cluster, because they are going to be charged for that. And so they are using agents so that each department has its own agent, and their kubeconfig files, their cluster secrets, their own Jenkins for that matter, they never have to give to anybody else.
Yeah, so that really removes a big vulnerability, right? If you had to share it with Spinnaker, which is an open source, you're really sort of closing that hole, which is excellent.
Right. So the Spinnaker admin, for example, doesn't need to have access to the cluster where we are deploying.
Yeah, it's great. That is good. Any other final questions? We're coming up on our promised 50 minutes. If not, if you go to the last slide, the next slide, if a little bit more about just general resources overall at OpsMX, we'll send these with the slides that you'll get. You'll also get the recording. And with that, we just want to thank you very much for your time today. And thank you, Srini, for sharing your knowledge about Spinnaker and how OpsMX can help and enhance and make it simpler to deploy to Kubernetes. And with that, everybody, I want to wish everybody, wherever you are, good morning, good day, good evening. Have a good day, everybody, and thank you very much. We'll
Thanks,
see you.
Mark. Thanks, everyone.
Bye-bye.
Cheers.